Section 14.8, change of variable, Jacobian. Let's start with the first example. Find Jacobian delta xy over delta uv for indicate change of variable. So we have the x equal -1/2 u minus v, and we have the y equal 1/2 u plus v. So let's check how we're going to find Jacobian. So here is the x and the y. Now, what I'm going to do here, it's going to be easier if you distribute 1/2, and the same thing here, distribute 1/2. So it's going to be -1/2 u plus 1/2 v, and y is going to be 1/2 u plus 1/2 v. This is minus, and when you distribute, negative sign is going to be -1/2 u plus 1/2 v. Then we're going to find the derivative with respect x with respect to the u, so it's going to be 1/2, and x with respect to the v, so it's going to be 1/2. And on the second side, we're going to find y with respect to the u, so it's going to be 1/2, and y with respect to the v is going to be 1/2. So the Jacobian is going to be x sub u and x sub v, y sub u, y sub v with absolute value. So it's going to be, which is the determinant. This one is the determinant, not the absolute value. So it's going to be -1/2 times, you're going to multiply these. 1/2 times 1/2, that means going to be -1/4 minus 1/2 times 1/2. So minus 1/4. So determinant, -1/2 times 1/2 minus 1/2 times 1/2. The result is going to be -2/4, and it's going to be -1/2. Then this is the result for the first question, which is going to plug in -1/2. That's it for the first one. We're going to do the same thing with the second one, find Jacobian. But we have x equal 4u minus v and y equal 5u plus 3v. Find x with respect to the u is going to be 4. X with respect to the v is going to be -1. Y with u is going to be 5. Y with respect to the v is going to be 3. Then Jacobian is going to be x sub u, x sub v, y sub u, y sub v is going to be 4, -1, 5, 3. Then you're going to multiply. Determinant for this one, that's mean 4 times 3 is going to be 12, minus 5 times -1 is going to be -5. And the result is going to be 17. So for the second one, it's just going to be 17. The same thing for number 3. They ask you to find Jacobian. So number 3, you're going to get exactly the same one, because there's no red color here. That's me, it's not going to change. So I'm not going to solve number 3. I'm going to go to number 4. Number 4, find Jacobian, uv minus 3u, and y equal u times v. So here's number 4. X equal uv minus 3u, and y equal uv. So x sub u is going to be v minus 3. X sub v is going to be just u. Y equal uv. Y with respect to the u is going to be v. Y with respect to the v is going to be u. Then the Jacobian rule is going to be x sub u, x sub v, y sub u, y sub v, and it's going to be v minus 3 times u minus v times u. Distribute the u here. It's going to be uv minus 3u minus vu. Cancel these, so the result is going to be -3u. So for number 4, it's going to be -3u. That's it for this example. For number 5, sketch the image S in the UV plane. So we have this image in XY plane. We need to sketch this one in UV plane. We have X equal 7U plus 2V, and we have Y equals 7V. So let's check how we're gonna solve this example. So here's number 5. So I did the graph here. I have these 3 points, and I have these 2 equations. So what I'm going to do, I need to get the new graph on this plane, on UV plane, convert it from XY plane to UV plane by using these 2 equations. So the first point is 0, 0. So let's plug in these 2 points here. That means 0 equal 7U. I'm going to consider this is the first equation, and this is the second one. So 0 equals 7U plus 2V, 0 equals 7V. You can solve it by elimination or substitution, back substitution, it's up to you. So from number 2, from the second equations, I'm gonna get 0 equals 7V, that's mean V equals 0. Substitute this one in the first one, you're gonna get U equal also 0. So the first point in 0, 0, 0 in XY plane, it became the same point 0, 0 on UV plane. So here is the same point. This is the point 0, 0. Now let's check the second point 7, 0. Plug in 7 here with the X and 0 with the Y. So here's the first equation and here's the second one. We can do exactly the same steps. So solve the second one. You're gonna get V equals 0. Plug in 0 in the first one. It's going to be 7 equals 7U plus 2 times 0. This is 0. That means 7 equals 7U. That means U equal 1. So this point 7, 0 in XY plane, we have 1, 0 in UV plane. So this point is going to be 1, 0. It's going to be here. So here is 1, 0. You're going to check the third point, 2, 7. 2, 7. Plug in 2 here and 7 here. So 7U plus 2V. And 7 equals 7V. From 2, 7 equals 7V, we can get V equal 1. Substitute 1, V equal 1 in the first equation. So 2 equals 7U plus 2 times 1. This is 2. Move the 2 to the other side. So 0 equals 7U. That's mean U equals 0. That's mean 2, 7 in XY plane became 0, 1 in UV plane. 0, 1. So our graph on this plane is going to be like this. On this point is going to be 0, 1. So we can now choose which one is going to be the right one. By just looking to the coordinate, you see here's the UV plane. We have 4 options, and this one is going to be the right one. So it's 1, 0, 1, 0, 1, and the point 0, 0. So that's it for this example. You got it right. Let's move to number 6. Now let's move to number 6. We're gonna do the same thing with number 6. Sketch the image in the UV plane. And here's X and here's Y. And we have this plane, we need to sketch it. This graph in the XY plane, we need to sketch it on UV plane. So let's check how we're gonna solve this one. So here's the graph. We're gonna do exactly the same thing, but before you start converting the point to the UV plane, make sure if you can simplify the equations. This is U, and here is negative V. So x equal half u plus v, and y equal half u minus v. So if you want to distribute this one in both these equations, it's fine. But what I did here, I multiplied the first one and the second one by 2. So it's going to be 2x equal u plus v and 2y equal u minus v. These two equations, it's easier to work on it than the fraction. So let's start with the first point. I'm going to start, this is the first point, then this one, and go back to the last point, half and half. So plug in x is 0 and y is 0 in these two equations. So we're going to get 0 equal u plus v and 2 equal u minus v. By elimination, we're going to cancel the v because they are different sign. So 2 is going to be equal to u. Divide both sides by 2, then u equal 1. Substitute this one, u equal 1 in the first equations. So it's going to be 0 equal 1 plus v. That's mean v equal -1. That's mean this point is converted to 1, -1 in uv plane. So here's 1 and here's -1. So here is the first point. Let's keep going to the second point. The second point, this is 1 and -1. Let's check the second point. 1, 2, here's the second point. Plug in 1 here and 2, 1 and 2, because this is x, and here's y. So plug in 2 times 1 is going to be 2, 2 times 2 is going to be 4. The same thing by elimination method, we're going to cancel the v. So 2u equals 6, that's mean u equal 3. Substitute in the first one, so give me 2 equal 3 plus v, that's mean v equal -1. So the new point is going to be 3 and -1 on uv plane. 1, 2, 3, and -1, so it's going to be here. So this point is going to be 3 and y is not y, v is -1. That's mean this point converted to this one. Let's keep going to the third one. 3/2, 3/2. Here's x and here's y. So 2 times 3/2 is going to be 3. That's mean 3 equal u plus v and the 3 equal u minus v. By elimination, so 6 equal 2v, that's mean 2u, that's mean u equal 3. Substitute in the first one, so v is going to be equal 0. That's mean our point is going to be 3, 0 in uv plane. So here is the point 3 and 0. The last point, half and half, this is x and here is y. So 2 times half equal u plus v and 2 times half equal u minus v. Cancel these, so it's going to be 1 equal u plus v, 1 equal u minus v. Cancel these two by elimination, so 2 equal 2u, that's mean u equal 1. Plug in 1 in the first equations, so 1 equal 1 plus v, that's mean v equals 0. So here is our last point in uv plane is going to be 1, 0. So here's 1, 0, 1 and 0. That's mean our graph is going to be here. This is our graph converted from xy plane to uv plane. So here on this one, we just have to choose the right graph, which is here's 1, -1, 3, -1, 3, 0, and 1, 0. So this is our right option. That's it for this example. We got it right. Let's move to number 7. Number 7, use the indicate change of variables to evaluate the double integral. Now we need to find the integral. Double integral of 16x squared plus y squared dA, and here's the x and here's the y. Let's check how we're gonna solve this one. So here is the graph. The first thing, we're going to convert these points to the UV plane. And then after that, we need to convert the whole integral here to the U and V and convert because we have the points here on XY plane. We need to find the border for the UV plane. So let's check that, how to find the solution. So let's do it step by step. The first thing, here is our graph and here is the points. We're going to convert this one. Here is X and here is Y. Again, when you have a fraction, always try to cancel the fraction by multiplying by the same number. So I multiply both these by 4. So it's going to be 4x equal u plus v and 4y equal u minus v. So here's the first one and here's the second one. Now I need to convert these 4 points to the UV plane, from XY plane to the UV plane. So I'm going to do the same steps like the previous example. The first point, I'm going to start from this one. 4 times -1 equal u plus v, and 4 times 0 u minus v by elimination. So it's going to be -4 equal 2u. That means u equal -2. Substitute this one in the first equations. We're going to get v equal -2. That means this point converted to -2 and -2 in UV plane, from XY plane to UV plane. The second point is 0, 1. Plug in 0 and 1 here. So we're going to get these two equations again by elimination. So 4 is going to be equal to u. That means u equal 2. Substitute in the first one, you're going to get v equal -2. That means 0, 1 is going to be converted to u is 2 and v is -2. So this is in UV plane. This is the second one. The third one is 1, 0. Plug in 1 and 0. So we're going to get these two equations again by elimination. So we're going to get 4 equal 2u. That means u equal 2. Substitute this one in the first one. So we're going to get v equal 2. That means this point became u equal 2 and v equal 2. Let's keep going to the last point, 0, -1. So 0, -1, plug in. So we're going to get these two equations, and then by elimination, you'll get -4 equal to u. That's mean u equal -2. Substitute in the first one or in the second one, it's up to you. You're going to get v equal 2. That's mean this point convert to the new point. So here's the points in XY plane, and here is the point in UV plane. Let's graph these points. We're going to get this graph. That means our graph changed to this one in UV plane. Now, next step, we need to find the area for this one. That means we already know u belongs to -2 to 2, and v is going to be belong to -2 and to 2. Then I'm going to convert everything inside the integral. That's our next step. Everything here inside, I need to convert because this one is written in XY plane. I need to convert it to the UV plane. So I'm going to plug in X here and plug in Y here. Let's simplify this one. Here's 16. This squared goes on both here and for the parentheses. So it's going to be 1 over 16. Find u plus v squared is going to be u squared plus 2uv plus v squared. That's mean you're going to FOIL this one. The same thing here. This is going to be 1 over 16, and here is going to be squared. FOIL this one, which is u minus v squared. Is going to be here. It's going to be u squared minus 2uv plus v squared. Now, if you distribute the 16 on both these two parts, 16 times 1 over 16 is going to be canceled, and this one also is going to be canceled. So the left is u squared plus uv plus v squared, and u squared minus 2uv plus v squared. Combine these together, that means these cancel. U squared is going to 2u squared, and 2 plus 2v squared. That means now we have this part here, we have the border. Now we have to find dA. dA, in this case, we're going to use Jacobian because dA is going to be Jacobian du dv. So we need to find Jacobian and multiply by du dv. This is our next step. Let's move to the next step. So dA is going to be Jacobian du dv. Here's the x and here's the y. Find x sub u is going to be 1/4. X sub v is going to be 1/4. Y sub u is going to be 1/4. Y sub v is going to be negative 1/4. Plug in everything in Jacobian. Find the determinant. So it's going to be negative 1/16 minus 1/16. And then it's going to be negative 2/16. And then it's going to be negative 1/8. So this is Jacobian. That means the integral for this one, 16x squared plus y squared dA is going to be, here's the border from -2 to 2, from -2 to 2, and here is going to be the 16xyz. Here's Jacobian du dv. This is going to be positive. Take the 2 as a common and simplify it with 1/8, so it's going to be 1/4. I can take 1/4 out because it's a constant. Du, so u squared plus v squared du dv. Find the integral with respect to the u first. So it's going to be u cubed over 3 plus 4, plus u v squared. From -2 to 2. Plug in. So it's going to be 8/3 plus v squared times 2 minus -2. So it's going to be -8/3 plus v squared times -2. Distribute this negative sign here on both. So this is positive. This is 2v squared. This one is going to be positive, and this one is going to be positive. Because -2v squared times negative is going to be positive. Combine these together. So it's going to be 16/3 plus 4v squared dv. This is our next step. So the next step, 16/3 plus 4v squared. We're going to find the integral with respect to the v. So 16/3v plus 4 v cubed over 3 from 2 to -2. Plug in 2 here, 16/3 times 2 plus 4, 2 cubed over 3 minus, plug in -2, 16/3 times -2 plus 4, -2 cubed over 3. So this one is going to be -8/3 times 4 is going to be -16 times negative is going to be +32. The same thing here. This is -16, -32/2 times negative is going to be positive. This one is +32. This one is +32 because 4 times 8. Add these because we have the same denominator. So it's going to be 128/3. Simplify this one with the 4. So it's going to be 32/3. That's mean our result for this example is going to be 32 divided by 3. That's it. We got it right. For example 8, I'm not going to solve this one. It's exactly like the previous example because you're going to get exactly the same numbers and the same x, the same y. So I need you to practice on this one. You're going to do exactly the same steps. And here's the graph. And find the double integral with the area r 32xy dA.